Thank you for joining us today. My name is Allison Van, and I'm the Executive Director at SPARC, a Center for Social Research Innovation. Welcome to today's SPARC Talk, the Augmented Social Scientist, using sequential transfer learning to annotate millions of texts with human-level accuracy. I'd like to begin the session by giving honor and thanks to the Haudenosaunee and Anishinaabe nations as the traditional inhabitants of the lands where McMaster stands. To say that is to acknowledge a debt to those who were here before us and to recognize our responsibility to respect and honor the intimate relationship that Indigenous peoples have to this land. We are thrilled to welcome Salomé Do, who is a PhD student at ENS and Sciences Po. Researcher focuses on methodological challenges faced using large language models for automated content analysis. She studies news framing analysis and explores how framing could in turn be a key concept for computational approaches to text. We are very excited to hear about your work, and thank you so much for joining us today.
Thank you. And thank you for this introduction and kind invitation. Can everyone hear and see correctly? Okay. So I will share my screen. Okay. I just want to... Okay. Is it good right now? Do you see in
Yes, it's great.
Okay. Please do not hesitate to interrupt me if you have any question. I will be very happy to answer them, or feel free to send them through the chat, although I cannot read the chat directly because I have my presentation on my screen. I want to introduce this talk by saying that the presentation will be based on the article that I co-authored with Etienne Ollion and Robin Chen, which is called The Augmented Social Scientists, using sequential transfer learning to annotate millions of texts with human performance. I just want to first introduce my background for a better understanding of where I come from methodologically. I think it can be important to precise that I come from a mathematics and informatics background at the beginning, and more specifically, in statistics and machine learning. So I graduated with a specialization in natural language processing mainly, and it's only later during my PhD that I specialized also on media studies, framing, and information and communication. However, my co-author Etienne Ollion is a sociologist, and Chen is also a PhD student who has a similar background to mine, but also turned to social sciences during his PhD. Now that I have made this little introduction, I just wanted to start by asking if some of you have did content analysis, and if you have not, you can just imagine yourself facing a large text or image or broadcast corpus, and imagine that you want to test an hypothesis on it and you want to test it quantitatively. So you have to annotate manually all your corpus. It is sometimes a painful experience to go manually through all the text, all the articles that a corpus has to offer. However, carrying this type of analysis can be very fruitful for research because you confront directly your theory to the experimental material, and you can revise the theory and go back and forth on theory and experimental material. So that is the good and the bad thing in content analysis. Sometimes still going through the whole material can be a painful experience. Our starting point was, what if it is possible to just have to annotate just the right amount of data to think on it and revise the theory and make a good codebook for content analysis, but without the hassle of having to annotate all the data. So that's the topic of this talk. Just to outline the talk, I will first introduce content analysis, through the lens of what is it, how it works, and what can we do about the fact that it is very time consuming to annotate a whole bunch of texts. I will then describe our concrete use case, which is strategic framing in the political press, and more precisely in the French political press in our case. Then I will go on by presenting the experience design that we use to test our hypothesis that we can augment content analysis. I will also present how we try to use supervised machine learning to annotate more text. And finally, I will present our results, which are promising for augmented content analysis. But also I will have some methodological discussion about the limits and the further work that we have to do better on augmented content analysis. So that's the outline. So I will start on content analysis. So content analysis is a quantitative method. It aims to measure potentially complex indicators or variables from materials that are more commonly analyzed through qualitative methods, such as text, images, interviews, broadcast, etc. So the idea is to reduce a text. I will say text for the rest of the talk because we are mainly concerned with text, but it also applies to images, broadcast, etc. And so the idea is to reduce text to one or more labels, variables, characteristics. And to do so, we have to create a codebook which defines and implements the way we will put this text or those parts of text in these categories. Sorry, pardon my French accent. And then there is a phase of going back and forth by confronting the codebook to the empirical material. And sometimes this does not confront very well. So for instance, say that I want to tell if a corpus of press articles are critical of artificial intelligence, for instance, or pro-artificial intelligence. So I will have to define what I mean by critical or pro, and confronting to the text, I will maybe see that there are some subtleties that I did not anticipate. So I will revise the codebook and go on for sometimes many steps before I have a usable codebook that I can use to annotate or have other people annotate a larger corpus. This approach has many critiques also. It is far from perfect. And most of the critiques include the fact that it is some kind of reductivism, because in content analysis, you consider that you can have only one interpretation. Maybe I simplify a bit here, but you consider that you can have only one interpretation of the text and the material, and this is the right interpretation, so you can put a label on it. This is reductivism, but also a very interesting critique to content analysis that we try to keep in mind in the rest is that counting frequencies of categories does not equate effects. So it is difficult to reduce complex phenomena that have complex effects to just the increasing in this category or this other category. Keep in mind that while content analysis can be good to produce quantitative data and quantitative analysis from corpora, sorry, you cannot draw any conclusion from it. And the last thing I want to say to introduce content analysis is that it is time and resource consuming. So our main idea was, can we teach a program to do the major part of the annotation once we have defined the categories? What is really important here is that the program, the algorithm, the artificial intelligence is not aimed to replace the researcher's work, but only to augment it and to replicate the coding designed by the researcher. So our two main research questions are the following. So can an AI code text with human performance? And how do traditional and what we call augmented content analysis compare? So can we show that an algorithm can do at least as good as human performance? Is the method viable? And the other question that we try to answer is what is the best methodological setup to do? Who should annotate the data? Do we have to have an expert annotating the data, or can we let students or even micro workers on the net annotate the data? And how much human annotated data do we need in order to then have a program that can replicate the content analysis coding on the rest of the corpora? In order to make things maybe a bit clearer, I just want to introduce our use case, which is that we want to do content analysis for strategic frames in the French political press, and more specifically the outlet Le Monde, which in France is an outlet that has existed for a long time. So we have a lot of past data on it, and it is very interesting to see evolutions and trends. And it is also a very wide outlet, maybe comparable to the New York Times for US people. This is our corpus. And I also want to introduce framing, which is a very interesting tool and concept in communication studies. So the most used definition of frames come from Ant-Man, who defines it as, I will quote, "To frame is to select some aspects of a perceived reality and make them more salient in a communicating text." So just when you take a photograph or film a scene, you make conscious or unconscious decisions about what should or should not appear in the photograph or in the scene, and how should things appear. So it is the same in text, and especially in the political media. And more precisely, scholars such as Capella or Patterson have raised the issue through two main books that have had wide success. So it's a Spiral of Cynicism for Capella and Is Anyone Responsible for Patterson. And they define strategic framing as a subtype of frame used by political journalists, which focuses on the issue through the lens of which candidate or party is winning or losing the political battle. It frames political issues in terms of games, competition, or even wars. How candidates and parties are doing in opinion poll is also a major concern in strategic framing. And it also puts strong emphasis on campaign strategies and tactics, motives, instrumental action, personality, and style of candidates, or even on meta coverage, so commentaries on the coverage of a candidate, or commentaries on the commentaries of the coverage of a candidate. And this issue is very important from a political standpoint, because there is a lot of research on how strategic framing impacts politics and the voters' preference, for instance, the individuals' visions of politics. And in France, the concept has more recently been included in the literature. So through essentially the works of Saïta and Kassiaf, who suspect that in French outlets such as strategic frames the journalists, have been reluctant to adopt this frame for a time, but they have anyway used more and more this frame, and the use of this frame is on the rise. This is this hypothesis that the strategic frame is on the rise that we want to test. I will introduce rapidly the experience design. So at first, we want to design two indicators, which we also call two tasks, that are direct experimental version and implementations of the strategic frame. And we want to test how they evolve through time. So the first indicator is sentence classification task, as exampled on the right. We classify sentences as belonging to two categories. First, the sentences that are classified as policy, which are the sentences who talk about the substantive issues, the reforms, etc. And the sentence classified as politics, which are the sentences talking about more professional politicians, their strategies, their intentions, and they do not belong to the first category. So this is our first indicator, and you have some examples on the right of the slide. And our second indicator is a detection of off-the-record statements. Off-the-record statements are unattributed speech. For instance, a journalist who was not allowed to quote directly a politician will say a source close to power confirmed that, or an unnamed official told government, etc. These tasks are interesting because they have varying difficulty. The first one needs requires to know a lot about political culture, and the second is more of linguistic based task. So you want to find segments in sentences that are similar but always turn a bit different in the sentences. But you don't need to have a very large political culture to do this task. So with these two tasks, we design three groups of annotators. The first one is the expert group. It's composed, which we call also the social scientist or the experts. It's composed of one or two researchers that are the experts on their field. So it's often the people who design the indicator. Second group are research assistants. So in general, these are trained, qualified students, but not experts. And they can have interactions with the researcher who can teach them the code book and give corrections on and feedback on how they code. And the third group are micro workers, or at least a modelization that we did of micro workers. So these are a bunch of people that are untrained, that do not know particularly well the subject of strategic framing, and that have very limited and almost no interaction with the researcher apart from getting a paper version of the codebook. And among these people, everyone annotates two data sets, which are articles. And so the first one is a train. It's called train because it will help train the AI model. And the second is a test dataset. And it's best defined by evaluation dataset. Just to set things maybe a bit clearer. So this is a summary of the datasets and the groups. So what is interesting here is that in the training set, we have only 63 articles for the policy versus politics task. And for the off the record, we have a bit more text, but it's also comparable size. And the test set consists of 11 articles. All these articles are sampled evenly through time, and they come from Le Monde. And the whole data set that we want to annotate with machine learning after consists of 65,000 of articles in order to give a comparison. So we only annotate very few, a very limited part of the whole dataset that we want to study. Just some words about the method and how supervised machine learning works. So I don't know the backgrounds of the people here, so I will try to explain briefly and, if possible, clearly. So there are three main steps, I would say, in supervised machine learning. So first, we have the training phase. So it's represented by the blue state in the graph. So you have an annotated, human annotated data set, and the model use the human annotated labels to try to learn how to annotate in the same way as the humans that have annotated the datasets. Then we want to know how our model performs. So we use the test set or the evaluation set that we left apart from the train set, and that is also annotated by humans. And we ask the train model to make predictions on the sentences on the test set, and we confront it with human annotated so that we can grasp what is the error and the mean errors that the model makes. So we have an idea of how the model performs on data that it has never seen during the training phase. And finally, once the model is trained and evaluated, we have the rest of the corpus, which does not have any human annotation here. And we use the trained model to predict the labels for each sentences. So we can make our quantitative analysis on these labels that were predicted, knowing that the model has computable error. This is the process. So I move on to the results of our study. So first, answering the question of can a model outperform or at least perform as well as a human? So on this table, we compared for both of the tasks, what the humans did and how they performed on the test set. So we had micro workers and research assistants annotate the test set. We compared this against how the researcher annotated the test set, and we compute what is called the F1 score, which is a metric that is the higher the better, and it can max at 1 and is the lowest at 0. So having something very near to 1 is good, and having something very low near 0 is bad performance. So we can see that the research assistants here are performing best on both tasks. However, we also compared classic supervised models, which have average performance, I would say, and lower than human performance. And we produced the result for our model, which uses the French version of BERT, which is called BERT is a large language model that is very similar to all the language models such as ChatGPT, etc. And it was maybe a bit more older than ChatGPT, but it performs really well, and it has the advantage of being that we can train it on a reasonable machine, and we don't have to have huge clusters Google or Facebook have to train this model. And we can see that it performs a bit lower than the research assistants, but a lot higher than the micro workers. So we consider that this is a very interesting result. And we go on by asking if we could have annotated less. So we produce these graphs where we run a lot of experiments and a lot of training with 10% of the train set size, 20% of the train set size, etc., in order to see how the performance goes with the train set size and if we could have annotated less data in order to save resources and time. And the curves that are plotted are the average performance for the algorithm trained on first the social scientist train set, the research assistant train set, and the micro workers train set. But keep in mind that these are all models and not a human performance here. But the metrics are performance compared to human performance. What we can see here that is most interesting is that for the sentence classification task, which is the hardest, the model trained on the expert annotation is the one that converges quicker and has the best results, as you can see on the left. And on the right, the thing that is interesting is that the model which performs the best is the one with the micro workers, trained on the data of the micro workers. And we analyze this as the fact that the experts provide very good data, annotation data, and training data for hard tasks. However, for the easiest tasks, the micro workers will have less data to annotate per individual, so they will be more focused on annotating, and maybe they will be less bored by the easy task also. And so together they can produce better training data than the experts. So that is our interesting conclusion here. So I will be very short on this part. It's the part that the social scientist wants to have, which is the prediction on the whole corpus. So here it's the 5,000 of articles, and we can see what is predicted and the changes through time and the tendencies for politics and policies labels. So this is the part where the social scientist can make his quantitative analysis and interpretation and validate the original hypothesis. But it's not my methodological interest here. So I want to close this talk by talking about the limits of this approach. So we show that we can have very few human annotated data and the model can work still with good performance, but it is difficult to know beforehand if the model will work and can work on the task. We proved it, but it's really difficult if you don't know if you want to run a model or not, if it will work before running the model. Running these models is computing intensive and requires programming skills. And the idea is that we don't want to replace the research work. So it is very important to say that the models do not help to find new categories or new labels in the corpus. It is not the right tool for this. So the models will not discover anything new. In a sense, they will only help to validate or invalidate quantitatively already stated hypotheses. Another point is to assess if more data is really better, even for quantitative research. And by this, if I do all by hand and do traditional human annotated content analysis, maybe if I sample my 200 articles, I can reach the same level of precision as if I annotate with this AI tool, like the 65,000 of articles. So this is a question that I ask in my thesis. I will not dive any deeper in this now, as I want to conclude, but it's another question that is interesting and requires a lot of statistics to be answered. And final limitation of this approach is that one day it may be replaced by a program which can directly learn from the code book, sorry, and spare the time to annotate a subsample of the corpus. So just to summarize quickly, the key takeaways are that we can augment content analysis for our task with good results that are almost comparable to the results of research assistants. Expert annotators are needed for difficult tasks. Lower level tasks can be annotated by non-experts, micro workers to gain time, even though this poses some ethical problems. And transfer learning models, I did not dive deeper into this aspect in the slides, but I can answer it in the questions. Enable to learn with good performance with few examples. So remember that our whole data set for policy versus politics is only 63 articles that are fed to the model to learn. And so just to say that my further work includes asking if annotating more data yields more quantitative precision. So thank you for your attention. And I just provided the link to our GitHub repository, which provides a lot of the code that the programming code that we used for this project. And it was coded to be highly reusable by anyone interested. So if you are interested in this AI approach, it is a good starting point. It is written in Python. So yeah. Thank you.
Thank you so much. We are open for questions and comments. People think I'll pose the first one. I've worked a fair bit with learning large language models, but haven't actually applied one yet. And what you were talking about in terms of not being able to know exactly if the model is going to work until you build the model. It's one of the things that I have struggled with in trying to figure out how far down this road I go versus the methodologies that feel very stable and comfortable to me. I have a strong background in statistics, but less in computing. And so it's definitely on my learning trajectory working with. And so I'm curious about what you've learned about considering whether or not it's worth that trade-off and the kinds of considerations that might go into that.
So thank you for your question. I think it really depends on how you have designed your coding task. And I think we need more accessible Python packages or even R packages to be able to run quick tests. You already have some human coded data because you have done a bit of research in content analysis for your study. And the idea would be to use this preliminary coding to test a model beforehand so you can see if it learns something or if it learns nothing. Yes, I think so. Sorry, to be clear, I think we need to have usable tools and simple tools to have this kind of quick tests beforehand. I don't know if it answers your question.
Yeah, it does. Thank you. Others? All right,
I can
I'm
ask a
guessing.
question.
Yeah.
Thank you for the talk, Salome. It was very interesting. My background is in humanities and specifically in literary studies, but I'm now doing research in education. I'm a postdoc at McMaster here. And we're doing research on generative AI and its use in the classroom and education. And so I'm listening to your talk about this tool and kind of thinking of uses. So I'm curious as to how difficult or easy it would be for somebody who has, let's say, beginner to intermediate programming skills, because my use case potentially could be I would like to do a large content analysis of syllabi, like course syllabi, to see how instructors are framing using your language, strategic framing, how they're framing the issues around generative AI, such as academic integrity in particular. How are they talking about um, generative AI use and framing it with an academic integrity, or let's say critical thinking, or use in the workplace or industry? What are the different ways in which they're talking about it, or to students in course syllabi, or maybe even course outlines, gathering potentially hundreds to thousands of syllabi from across Canada or even Canada and the US, and then running this? I'm trying to think of how it could be transferred to that domain. Does it seem like an application that makes sense, or is it not worth pursuing, in your opinion?
I think it makes a lot of sense. And I want to precise maybe that this approach for augmented content analysis is not specific to strategic framing. It's only our use case to have concrete data on which to rely. But to answer, I think, your first question on what would be the programming skills required, I think for the moment and with the tools I know, I think knowing the basics of the programming language is required. I don't know of any or equivalent for the moment. However, it might come maybe in the future. And I don't know if we have the time here. I think maybe we are a bit late on time, but I think that we produced some kind of tutorial to reuse our code in the GitHub repository. And even though the code is not perfect, we try to design it so it can be very modular for people to reuse it without diving in all the AI packages and training. I would be very interested for feedback on this implementation that was aimed to be reused, even though it's not industrial level repository. So
Thank
I don't
you.
I answered all your questions.
Oh yeah, definitely. And I do see the Google Collab book here. I had your GitHub open, just going through it to see. So thank you.
Thank you.
There's a question from Daniel in the chat. Would you say that this specific model may be more robust with hard data in sciences and math content? Or do you think the off-the-record aspect has greater impact than the direct classifications?
Let me just reread the question.
And Daniel, feel free to jump on if you'd like and say more or reframe it.
I have a doubt on what Daniel meant by hard data.
Sorry, hopefully you can hear me, not too loud. I just wanted to, because you talked about how you have the extra nuances with the language where you have to start looking at the off the record piece that is not directly saying yes, no. And in comparison, in a lot of science and math content, it's a very hard, the numbers are more robust. There is that more generalized aspect of what you could or can't inference from it. But do you think with using your model, having the hard data there which would pull more to the direct classifications where you had with your policy and politics, has more power for the model to learn? Or do you think the off the record piece is more important with this design?
Maybe to add precision. So the off the record was, in fact, so it is a easier task for human annotation, I think, but for training, it was harder, in fact, because we struggled on one aspect particularly, which is the fact that the off the record statements are very sparse in text, even though it's on the rise in time. It's not everywhere in an article, so it is hard to find in articles, and you have to review a lot of articles to find enough signal of the record statement for the model to learn something. It was other task for the model to learn, and we had to adapt our approach. I did not dive into the specifics because I wanted to be clear and do not take too much time. But we had to oversample of the record by using a weaker classifier at first. So the weaker classifier was actually very easy to implement classifier, which told us the probability to see off the record statements in an article or a 3-sentence excerpt. And with this, we could oversample off the record statements in the training set. And that's why we don't present inference results on off the records for the moment, because with this oversampling in the training set, it could have a bias on the results in inference. So we have to dive deeper into the more statistical project that I talked about before, of how do we make the link between classification with the model and quantification, and by that estimating the prevalences of the categories on the overall corpus. So yes, I don't know if I got your question. That
You did answer it. Thank you.
okay.
All right, I know we are over time. Thank you so much for joining us. And yeah, we look forward to future Spark Talks this term and hope that people will join us going forward. We've got some really exciting talks.